announcements and sound. We're introducing the football game challenge. Well, we've been playing it all weekend, but if you weren't part of that, then we're doing it again now. We're going to give a little bit more background this time, though, a little bit more in depth. This is aimed at 7 to 18-year-olds. And so we've got activities for all ages. Then we've got a family, a group activity to make a poster during the summer. If you're in the Northern Hemisphere, if you're in the Southern Hemisphere, just make it a family project, make it a group project, a school project. It could involve, if you're doing distance learning, you can give different segments to different parts of your class, and they can even work together through distance or work with everyone in their home, or they could, you can differentiate it. So you can give the lower attainers one job and the higher attainers a different job. So there's lots and lots of flexibility with this. So I say that, but I'm actually right now talking to 7, 8, 9-year-olds ish. You ready? We're going to play the football game. So now some of this will be make a note, come back later, replay the video. Fortunately, it's got sound now, so you can actually get some benefit out of it. And I've just got to find the activity that I'm looking for 7, 8, 9-year-olds. Or actually, this activity, we are going to start with something that's meant for younger learners, just to get you into the flow of it. Okay, so this is to get you started. Now, a lot of this is repeating what we did over the weekend. So if you did the activity over the weekend, then feel free to go away now and come back in about 15 minutes. When we're talking about the poster, we're just going to give more detail, and the more detail is really going to be for 11 to 18-year-olds. So if you have already done this, then go and find one of our other videos. Go and click on the videos in the Making Maths Fun for Kids of All Ages, and in there you will find lots of different activities. There's early years, and the pictures are hopefully give you a clue, but just play them and see. Once you play them, you'll see what the title is. But they're all meant for to be enjoyable. And so go ahead if you've played this. If you haven't played it, then follow along. And the objective here is that we build you up to a point where you're ready to make this poster as a group, whether that be a family that's at home or whether that be a group of friends. That you could do it over Skype, Skype. Who uses Skype these days? Over Zoom or WhatsApp, or I wonder what you're using. Let's put that in there and start. I've just started a watch party as well. So I wonder what Skype are doing. So, oh, I remember. Yes, it's Teams. I remember now. Yeah, Skype's no longer of interest. Okay, so we've got these numbers. That's a plus. So we have 2, 2, 3, 4, 5, and 6. The first challenge is to put those numbers into that sum, and the question is, one question would be, is there more than one way of doing it? Can you find more than one way of doing it? That would be your extension. See if you can do that. So that's the first one. Make a note, keep working on it, or come back and replay the video. Okay, because that one's, well, I'm going to put the next one down here. This time, you've got to find the numbers that make that work. Now, so these are all units. So these are digits, not numbers. You're looking for digits. So this is units, and this is the tens column. So those are units you're looking for 2 digits, digit for A and a digit for B where that is true. And again, can A be, what possible numbers can A be? Can A be? Can A be? What digits could A have? What I like A B. That's a little double entendre. And so it's for you to work it out. What possibilities are there for A? And then what possibilities are there for B? And can A be any other digit, and explain why or why not? So that's challenge number 2. Now, challenge number 3 is on the activity, and I'll let you, how am I going to do this? You know what? We're going to do that way. You've seen that now, so that was my introduction. So this is the next one. It's a code. And why are we doing all this? Why are we playing these games? And why are these games? Can you see that well enough, hopefully? Right, I'm now going to put numbers in here in a different. So what you're doing is you're developing skills. You're developing skills, logic skills. You're developing your skills with, all you're doing here is adding, but the really important one is the place value. That is absolutely critical to working this one out. That's worth 10, that column's worth 1, that column's worth 10, that column, each of these numbers is 100, and each of these digits is worth 1000. Okay, so that's the standard that you've got here. I've said that. I've just given you a clue. I've just preempted myself and given you a clue. Right, now, this is a code. This is a code for you to work out, and your clues, your key for your code book, you open up your code book, and in your code book are the keys to these numbers. And the key is A equals 5, B equals 6, E equals 7, F equals 1, G equals 8, L equals 3, M equals 2, the letter O equals 9, and T equals 4. Using that key in your code book for that matrix, what is the message? So I am going to do it with you because I do want this here, and I'm going to put it a bit further up here. Okay, so the message is, what is the letter A? Have you got your pens already? You're doing it? Okay, letter A. Let's start with number 1. Where's number 1? Let's do it that way. Oh, no, let's start here. Letter A is 5. Let's find the 5s. There's letter A. Excellent. We've done that one. Letter B is 6. 6 is there. Letter E is 7. 7 is there. What do you think it says? What is the message? Letter F is 1. Letter G is 8. Letter L is 3. Oh, there's 2 of those. Oh, it's got a ball in it. Letter M is, letter O is 9. 2 of those. So the last one must be 4, yes, and that's the name of our game. So and you can create your own codes and see, you know what, that would be a nice challenge. See if you can make any other words that fit. Now, what's really important, and the reason why we've got letters, is that these letters can be more than one, can have more than one digit that works, because the next thing you've got to do is, what is the relationship between these numbers? Because they are connected, they are all connected. So what is the relationship between them? Shall I? Is that true? Does that work? Okay, so that's your key. That's your other key, is that when whatever numbers, so what we're going to be doing is we're going to be working on a poster where we have all the possible numbers in this that will, in other words, those two will be repeated, those two will be repeated, that plus that will be that, that plus that. So where these are all, where this works, no matter what. So it'll only add up to 4 digits. Every number is a 4-digit number. And you've got that none of these numbers are repeated. So if one of the things we're going to tell you is that O can only be 0 or 9, for example. So if O is 0, then none of the other letters can have a code of 0. So each of these letters, let me get the succinct way of saying it, because it's written here beautifully and right now it's not coming out. So each letter represents a different digit. So every letter must have a different digit to any of the other letters. Okay. So it's a matter of finding all the numbers that keep that relationship true using these letters. So all the different possibilities for the letters. So you'll end up with a poster. I'm going to get rid of that now. Oh, I hate it when I'm in class and the things rubbed off the board and I haven't finished it yet. But you know what? You can replay the video. Now, so what you'll end up with is a poster where you've got foot, ball, game, whoopsie, and then the number of basically the count. So the first option we've got here is foot is 1994, ball is 6533, and game is 8527. Now there are a total of 244 possibilities. Now, why do we know that? That's the sort of thing that mathematicians do. Mathematicians find these things out and prove it. So that's the challenge for you. This is a project for the whole family, or you can do it a group, you can do it with your class by remote using Zoom and things. And each one can have a task, but we're going to go into making that systematic. So the important thing we're learning here is being systematic, using logic, and also we're going to be practicing lots and lots of arithmetic and lots of place value here. So, and some of us will be coding. When we get further down in a minute, we'll find there's some help with learning how to integrate this into a coding exercise so that you can actually get a computer to come with all 244 solutions for you. So that's a separate exercise, but the poster is, now the great thing with the poster is that you can include everyone in the household. So the older learners can make some of the arrangements, but what the older learners can do is more facilitate the younger learners. So be a teacher, and the younger learners, the very young, you could even just give them 10 counters and get them to count out and double check that makes that number. So 4 counters and 3 counters, and count that there are 7 counters. If they do that, that's the really young learners. And then as if you've got someone who can add 4 and 3 in the digits to make 7, that can be theirs. And then as they can just keep it as simple as adding 2 numbers together. So that and that is going to give 1 left over. So you might be learning that then has to be 10 plus 5, because we had 12 here, so we can only write 2. There are 2 10s, but 12 means we've actually got 100. So getting all that and doing it again and again and again and again and again will really help those younger learners to move on a step or get lots of practice, so they're much more confident and have a great feel for how to do this kind of sum without making it tedious, because it's not about doing the addition, it's about filling in the poster so you have 244 different options. Now, what we're going to investigate now is how to make it systematic and what processes we can do with it. Let me just make sure I'm in the right place. Okay, so the next step is to just take it one step at a time. So we've done with the code. Oh yes, and what I was saying is with the code, find what other numbers you can put in there. Well, in the process of finding other codes, you're going to be finding other bits you can put on your poster. Now, the first poster might be a bit of a first draft, and then you might want to go back and make your poster, put the numbers together in such a way that they're really systematic and you can look at it and you can even know where to find a number, because and I'll give you the first number. I will give you the first number when we're ready to actually say, right, do the poster, go. I'm going to do it as well, by the way, and I'll be posting regular pictures up and a link back to this video, or maybe the YouTube video, because there'll be a YouTube video on this specifically as well. So yeah, so I'll be creating this poster over the summer as well. All the projects that we're doing, I'll be doing them over the summer or winter if you're in the southern hemisphere. Right, now we've got that. I'll leave that there, but I'll leave those numbers there and I'll get rid of this. We might need those numbers again in a minute. I don't remember. I have to say, I don't remember. Memory, just call me Dory. How do I actually develop a better memory? How do I develop a better memory? That's a good question to ask. How do I develop a better memory? I have a great memory. I just have to learn how to use it. Right, I'm learning how to use it. So the next exercise is B. B plus A equals A, C, C. Again, find the numbers, put the digits in place so that the sums are correct. There's another one. P, Q plus Q, R equals Q, R, Q. Again, find the digits so that the sums are correct. And again, is there more than one solution? If yes, what are they? And when? And find all the solutions. And how do you know you found all the solutions? And if not, why not? Now, so we're using what our motto here is, well, our guide is think to succeed. So we've got to keep thinking. To fill out the whole poster, we're going to have to keep thinking. So what we'll find is we'll get some numbers, we'll find a sequence. Ooh, we found a family of numbers here. And then you'll go dry and you'll think, okay, those are all the ones that are connected. Now, what's the next family of numbers that we're going to look for? So every time you go in between, in order to get systemized in that way, you'll have to think to get to that point, and then think to open up the next family of numbers. And then we've told you that it's only 244, and we're also giving you the information that O can only be 1 or 9. The letter O can only have the digit can only have a value of 1 or 9? Not 1. Oh, what? Sometimes of 0. Scratch what I just said. Good grief. 0 or 9. It's because I've got the O there. I can't write 1, can't write 0 there. This is a 0, like if you've ever done, in the olden days, we used to write zeros like that when we were coding, so that we used to call it programming, so that you could tell the difference between the letter O and the number 0. So we'd write it out like that. And so I'm just differentiating there. Right, so for these, looking at these, think to succeed. Oh, this is oh, sorry, I was jumping ahead here, jumping back to this bit. We're going to stick to this bit for a moment. So here are the questions. What have you found out yet? Have you worked out what the numbers, what is the largest number that B could be? Okay. And remember that this row here it's got 3 digits. Now that means that that's 100, that's 10, and that's what I should actually say, and that's worth 1. What I should say is A cannot be 0. This actually should be a qualifier here. A can't be 0, because this has to have a value. This last one has to have a value. So A can't be 0. So what's the largest number that B can be? And so what is the value? You might be able to work out the value of A from that. So you could find a solution, and then once you've found a solution, are there any other solutions? So one solution could be, so I'm going to say that A has to be 1, because the largest number that B can be is 99 plus 1 is 100. Are there any other solutions? Are there any other solutions? Could A be any number other than 1? Well, I'll let you work that out. And can A be, and if A was 0, the very largest that could be, if A was 0, then the answer would be 99. We would have a blank there, and we can't have that. That has to be a number. So we know that A can't be 0. We know that A can be 1 if B is 9. So now then, what's the next number down? And remember that they've both got to be the same number. B and B, they're both the same. So let you think about that. What other possibilities are there? Right, and then for the other one, is there a number that Q has to be? And what is it and why? And therefore, again, you've got to think carefully about, you've got to have, Q has to have a value of it can't be 0, because otherwise this number would not be worth 100. So I'll let you think about that one. There are extra prompts and help in the activity pack. So we're now going to the challenge. We're going to make our poster. But before we make our poster, again, I've got a few bits of extra help for you here. This is where, okay, a few bits of extra help. We want to replace, for this one, we're going to replace the letters in the word ball for numbers. And in this one, we're going to replace the letters T, L, and E. So we're looking for relationships. We're looking for what is the largest, what are the limitations on what T and L can be. We're looking for, that one's quite easy, just do a subtraction. For this one, we've got to be a little bit more, now that one's going to be a 9. So what are our limitations on here? Do we have a number? And remember, we've used 1. We've used the only number that you can look at the numbers we've got available. So we've used 2, we've used 3, we haven't used 4, we've used 5, we've used 6, we haven't used 7. 1, 2, 3, 4, 5, 6, 7. Wait a minute. 1, 2, have I got that right? 1, 2, 3, 4, 5, 6. 6 isn't in there. Oh, yes, it is. 6 is in there. 7. Okay, I've just lost the plot. Oh, I know what was missing. 0. Oh dear. We've got 0 to 9. Oh, does that ever happen to you? Right, so those are the only actual numbers we have available to us. Now we can look at some relationships between them, and now I've lost the plot again. I can't see how any of those numbers added together can actually give this solution. Right, I didn't actually test this. As you can see, I didn't test this beforehand. I just assumed that was right, and I can't see how it's wrong. Okay, I'm going to have to come back to that. So you can work on it. I don't have to solve it. You solve it. You help me out here, please. I get that. I might have a place where I can look quickly. 199. 1994, 7 or 0. 1994, 6, 5, 3. Oh, I found out what I've done wrong. Have you spotted my deliberate mistake? I've just realized what my deliberate mistake is. See if you can spot it. See if you can spot what my deliberate mistake is. Okay, it wasn't deliberate. It was a genuine mistake, and I make magnificent mistakes and I learn from them, and I'm actually quite happy to do that. Okay, so we're nearly done. We're nearly there. We've just got to think about a couple more things, and that is the relationship between. So we're giving you that the letter O is either 0 or 9. So if O is 99, then if the letter O is 9, then we've still got 0 available. If the letter O is 0, then we've still got 9 available, if assuming it's not being used anywhere else. Okay, now second to last thing, we're going to look at the relationships. We're going to look at the relationships and how to work out, for example, okay, right, we're going to put the letters in. I don't want to reveal it now that I've worked it out. We'll put this one in. We'll put that one in. Let's see if I get it right. You guys might need to help me here. So that's 1, so that must be 7. And that must be 7. And that's all right. So that's not 9, and those are the same. Yes, and that is 3. Hopefully I've got that right. Again, check me for it. Okay, so Now, why should 0 and 9, why should O always be either 0 or 9? It's that the proof is actually in the activity. I'm going to let you look at that because it's just amount of time you're given that 0, 9. You would love you to actually work out why. It'll probably come to you as you're doing all the additions, and then you can check it out. It's in the activity. And then we've got a limitation. We've got more limitations. So we've got the relationship between T and L, and especially when that's 0, it's that being 0 or even 9, we've got a limitation on what can happen here. So if O, the letter O, got a L there, equals 0, no, if it was 9, then M minus L, then M equals, right, I'm not going to actually do this part. That's not my forte. My forte is not stand in front of a board and help you work these things out. It's very clearly stated. I did go through this last night and I did go through this morning, but it's not something I'm experienced in. I'm not a teacher and I don't want to bore you and get it wrong. So as you can see, it's very clearly stated in the activity pack, much more clearly than I could ever do it, because all I'm going to do is mess it up and confuse everyone. So please do look at it in the activity pack. There are relationships. The relationships between these numbers, the fact that these two are the same number digit, these two are the same digit, it controls what's happening, and you're forced to use the relationship between all these numbers. You've got the same two numbers there. Those relationships matter, and there's only certain numbers you can put in. And that's what I was saying earlier, maybe you could make codes so you can find words, and then you can make codes with other numbers and see if you can find a sequence of words where by putting in different numbers, they actually also work out. So that's an extension that you could do, and that'd be something maybe you could do in upper secondary. But the other thing you can do is write that code. And on page 8 of the activity, there is pseudocode. So the pseudocode, what it does is it shows you what each step must do in whatever code you write. So you could write this in Python. I'm sure use a Raspberry Pi to work this out. I don't know and much about coding these days. Back in my day, we didn't use, we had different codes, but they're all based on the same things. They're all based on ones and zeros, and that's the foundation of it all, is binary. And so it's actually a lot of time and effort has gone into creating this pseudocode, and this pseudocode on each line shows you what each line must do, and then it also describes it. So you've got a little pseudocode, and then you've got a little description, actual description of the activity, which means that you can write your own code without having to spend hours and hours and hours working it out, or you can spend hours and hours and hours working it out. Please do. Be a hugely valuable activity to you if you can find write a code that gives you all the 244 solutions. So the last thing I'm going to do is I'm going to give you the first line. So this is going to enable you to start at the beginning and see if you can fill in all the numbers starting at the very beginning. So the lowest number for foot anyway is the lowest number for foot. So we're going to, the system that we've used is that the lowest number for foot, and then work systematically by increasing that number, but finding all the different possibilities for foot being equal to 1004. And it is 392. And so that's the first one. And there are 233 more to find. And if you can do it systematically on a poster, then that would be super grand, and you'll start seeing patterns, and those patterns will start helping you figure out the next. So you'll find groupings, and each grouping will help you figure out the next grouping, and so the patterns within each grouping will help you work out the patterns for the next grouping, and that will be a fun project. As I say, I'm going to be doing it as well during the summer. I should be creating this poster, so that will be hanging on my wall. And what you're going to be benefiting from all of this is making a plan, working systematically and efficiently, which is just useful in any task you're doing, whether it be schoolwork, homework, for later in life. If you're going on holiday, you're going to pack all the right things. You've got to be systematic, or else you get there and go, oh, Mom, where's my charger? But if you're systematic and you make lists and you work out everything that you need, then that will serve you really, really well in life. Or else, another thing you can do is, if you haven't charged up your device and you end up with no battery, so that's part of being systematic too, is making sure you have enough battery for what you need to be doing. And so we're thinking logically, giving explanations. Again, it's a really good practice for real life. And then and learning on your own, like learning even as a group, but each one individually still being proactive, and everyone coming up with their own ideas and including other people. So you're learning how to work in teams, which will be huge, whether you want a job and you're working in teams, or you want your own business. You'll need to, even harder, you need to lead a team. You need to know how to work in teams and collaborate and working with people. It's all huge, wonderful benefits, and hopefully you'll learn more deeply that whatever level that you're at, that will be your little stretch, whether it be just adding 2 digits or recognizing digits. If you've got any young people who don't know their digits yet, by the end of the summer, by the end of the poster, they will know their numbers. You'll have said them so many times, but it will be their job to write them on the poster. Or they could have their own poster where they write, if you want to be super special with yours, they could have their own poster that they write the digits on, so that they get lots of practice in writing the digits, and they've got to be right. And although it won't matter too much, depending how old they are, it might not matter very much if they're right, as long as they get the practice writing them. And identifying the word 8 with the symbol for 8, and then you can even like get them to count the 8 counters for every time they write it. And right, okay. If you are enjoying these videos, please do share them. Please tell other people about the group Making Maths Fun for Kids of All Ages, and tell them about the Aiming High website, which is where all these activities are coming from. Since the COVID incident, the Aiming High website has been developing, or adding home learning activities to what was originally written for teachers, and that's the teachers that attend the AIMSEC courses, professional development for teachers in Africa, in mathematics. So they learn better techniques, always improving their maths teaching techniques, and there are lots of teachers that come from disadvantaged communities, and they get bursaries. And the fundraising that Bubbly Maths does is for bursaries for those teachers. And what the advantage of that is, they are giving a better education to the children that live in poverty in rural and disadvantaged areas in Africa. So by using these activities, you're supporting AIMSEC, and therefore helping those children get a better education that gives them a chance to rise themselves out of poverty through education. Who knew? So we've also got the YouTube videos pages. We've got math toys. It's all in the welcoming introduction section at the top of the page, at the top of the group, and that's maths toys. And if you'd like to subscribe there, then every time we get a new video in, you'll know about it. So that'll be all videos like this, great activities. They can be projects, all about learning covering all ages, so you can do family learning. With all have the links to the Aiming High activity. And then there's the Bubbly Maths YouTube channel, which has all these daily lives, and it also has lots of other fun videos with soap bubbles and balloons, doing maths with soap bubbles and balloons. And then we're also starting to put up videos about my brain just went about my brain has completely flown the coop about maths anxiety. Want people that have difficulty of learning maths because of difficulty just feeling bad about maths and hating maths and things. So it's help with that, help for families with that. Okay, let's have a look, see if anyone has joined us today. Look through the round window. I can tell you my age now. Have a look through the round window. We've had Henrik. Henrik wants to know if I have a background in programming. Oh, Henrik, what was the thing you asked last night? Oh, no, it wasn't. It was, I had a question. It wasn't here. It was somewhere else. The question was, oh, what was the letter? The letter was, oh, I can't remember. We'll have to look at it. I have to, it was one of these letters could be 0. And I can't remember what the letter was. I think it might have been M. Oh, I think the question was, can the letter M be 0? So can the letter M be 0? I think that was the question. And I can see the answer, but it also depends. It depends what all the other numbers are, doesn't it? So hi, Eddie. Hi, Lucy. Hi, John, Frosty. Hi, Russell. Hi, Helen. Hi, Feliki. Hi, Henrik. I'll answer your question in a second, Henrik. Joanna. Salvo, hello in Southend. Noeli in Tanzania. Oh, I addressed my memory issues earlier. What memory issues? Salvo says, if I stay young, my memory will remain with me. So there you go. Stay young. Thank you, Salvo. And Terry visited us as well. I don't know if he's still on. Andy and, oh, hello. How are you doing, Dov? Good to see you. Your young ones might enjoy this. I hope so. So Henrik, yes, I got a degree in electronic engineering. I'm the founder of Bubbly Maths. So my mission in life is that every child on earth will love learning and enjoy mathematics. When I discovered AIMSEC, I thought, yes, I want to help this organization with the children in Africa. But my mission is that every child on earth will love learning and enjoy mathematics. But before that, I was an electronic engineer. And when I worked in industry, I was a test engineer. So obviously, if you don't know, you wouldn't know. You have to do some programming when you learn electronic engineering, because it's about computers and about, also I did electrical, so you have to control things. You have to do programming to control robots, that sort of thing. And then my first job was a test engineer, which means I wrote lots of programs to test circuit boards. And then I started writing programs to simulate integrated circuits and microprocessors and things like that. So you have to do, use logic and keep a lot of information in your head. Ironically, even though it's all in the computer, you've actually got to keep all the connections going in your head as well. So that was an interesting job. So thank you very much for joining. I will now find my way to where, and I should be good at this sort of thing because I am an electronic engineer. And it's all good. I can do it. I'm 58 years old and I can do this. I have a lot of experience. So I should get better at it as I get older. Thank you. I'll see you 10 o'clock. Whoa, 15 minutes. That was a long session. In 15 minutes, we'll be back on with the early years session. Thank you so much. And that's Caroline from Bubbly Maths signing out. Thank you.